Hello everyone, good afternoon to all. Hello, good afternoon to all. Okay, I'm launching the technical polls. Just respond there whether my voice and screen is clear or not. Okay, just respond to the polls whether my voice is clearly audible to you all or not, and my screen is also visible clearly or not. I hope everything is good. Okay, so I'm ending the polls and we'll start now. Okay, so this is our third lecture of complex number. Today we are starting with argument of complex number. Yesterday also, in the last class also, I told you about the argument. What is argument of a complex number? Okay. So let's start from there only. Okay. Clear? So let's start. So what is argument of a complex number? Suppose you have a complex number z. Suppose we have a complex number z, which is x plus iy, right? If you have a complex number like z is equal to x plus iy, so how we can find the argument? What is the meaning of argument? First we will see. Okay, suppose if we'll plot this number, if we'll take this number in the Argand plane, suppose this is my point z or complex number z, which is x plus iy, right? So what do you mean by argument? Now the angle made by this complex number with the positive x-axis. Okay, so if you'll join from origin to this point, so what is the angle made by this complex number? Suppose this is my theta. So this is actually my argument of the complex number. So how can you find the argument of a complex number? Very simple. Okay, it's very simple. Suppose this point is my P and this is O. If we'll drop a perpendicular from this here, and suppose this point is M, right? So that means to reach these points, we need to move from origin to point M. Suppose I'm taking, because this point is x plus yy, then the coordinate of this point P is xy. If the coordinate of point P is xy, then this is my x unit and this is my y unit. Okay, so the argument, what is the argument here? Argument is actually my theta. So theta is my argument because the complex number making an angle with positive x-axis, that is theta. Is that clear to everyone? So let's find theta. How can we find the theta? Theta is actually, if we'll take, we have the informations, that is this length is x and this length is y. Okay, so if I'll ask you to find tan theta, so tan theta will be y upon x, and we know from in the last class also I told you, if tan theta is equal to x, then theta will be tan inverse of x. Yes or no? So similarly, if we use this rule here, so my theta becomes tan inverse of y upon x. So this is my argument of this complex number. So what is the argument? Remember, the angle made by the complex number, the angle made by the complex number with the positive x-axis is my argument. So this is my definition of argument. I hope this is clear to all of you guys. Everyone is clear? Is there any doubt? You can ask. If you have any doubt, you can ask it. Okay, so always this method will not work. So let's see. And some important notes for you also here. First point is argument of a complex number is mainly valued function. If theta is the argument, then the number, or we can say 2n pi plus theta is also argument of the complex number. Simple things. Okay. Suppose here we have a complex number. This is my argument theta. Okay. If I'll say I will move 2 pi first, then I will reach here. Then this is also my argument. So 2 pi plus theta is also my argument. Okay. 4 pi plus theta is also my argument. I can say or no? Yes, you can say. Yes or no? Right? So similarly, generally we can say 2n pi plus theta, where n belongs to the set of integer, is my argument. So if you move 2 pi and again reach there, then that is also an argument of the complex number. That's why it's not a single valued function. An argument is not unique, we can say. Okay, argument is not unique. Okay, that's why I can say 2 pi plus theta, 4 pi plus theta, 6 pi plus theta. Generally, we can say 2n pi plus theta is my argument. So argument is, remember, argument is a multi-valued function. Is that clear to everyone? Okay, good. Move to the next point, that is the unique value of theta such that, okay, now we are introducing the thing that is principal argument. Okay, so what is principal argument? Now when theta belongs to minus pi to pi is my principal argument. Okay, when theta belongs to minus pi to pi, then we can say that is my principal argument. Why we are taking like this? Yes, because no problem. Suppose here I am taking a complex number z. Okay, and this is my argument theta. Okay, and if I'll say okay, this is also suppose I am taking another complex number. This is my z1 and this is my suppose z2. Okay, so this is also, suppose this is my theta 1 and this is my theta 2. Then argument, what is argument of z2? Argument of z2 is what? You can say, what is that? The angle made by the positive, the angle made by the complex number with positive x-axis, right? So you can say, sir, this is my theta 2 is my argument for z2. Is it correct? Yes, it is correct. But we can say, what is the principal argument? Now, if I'll ask, what is the principal argument of this complex number? So then what I will do, I will move in anti-clockwise direction. Okay, I will move from clockwise direction from 0 to minus pi. Okay, and if I'll move, then argument of z2 will be what? That is minus pi plus theta. Minus pi. First, I will find this angle, and then minus pi plus theta I can say. So this is belongs to minus pi to pi, right? So this will be my principal argument. This is my principal argument. When the angle is lying between minus pi to pi, where minus pi is excluded and pi is included, then I can say it is my principal argument. Is that clear to everyone? Yes or no? So because argument is a multi-valued functions, to make it unique, what we invent, we discover the principal arguments. When the angle lying between minus pi to pi, where minus pi is excluded and pi is included, then we can say that is my principal argument. Is that clear to everyone? Okay, so you can ask also here, sir, why minus pi is excluded, pi is included? Suppose we'll take a point, we'll take a complex number z3 which is lying on the negative real axis. Okay, so what is the argument here? You can say, sir, pi is my argument. That is, if pi is argument, this point, this number can be lying here also. So for this also, argument will be pi. For this also, argument will be pi. Is that clear or not? So that's why we are excluding the point or the number minus pi. Is that clear to everyone? Okay. So if it is clear to everyone, let's move to another thing, there is a unique complex number which is 0 or 0 plus 0i. Its argument can't be defined. Argument cannot be defined. Remember, only one complex number which is 0, which argument can be defined. Okay, because suppose here this is my complex number 0 plus 0i. So what is the angle made by this complex number with positive x-axis? Its direction. In physics also, you studied all this thing. In case of zero vector, there is any angle? No, because its direction may be this, its direction may be this, its direction may be this, direction could be this. So there is not a single direction. Is that clear or not? That's why the argument is not defined in case of 0. It is defined by magnitude only. It is defined by magnitude only, or we can say modulus only, because 0 plus 0i, which modulus is 0 itself. Clear, everyone? Remember, in case of 0 is the only complex number where the argument can't be defined. Clear, guys? Okay, sure. Okay. If it is clear to all, let's move to the next thing. Now, okay, for you, there is one example here. Okay? There is one example. Suppose if I'll ask you to find the argument of the complex number z is equal to -1 minus I. So what will happen? What should be your answer? You can say, sir, we know the formula to find the argument of this complex number, because theta is actually tan inverse of y upon x. If we'll apply this method, so theta will be tan inverse of y is -1 upon -1. So this becomes tan inverse of 1, right? And which is pi by 4. But it is wrong. Its argument can't be pi by 4. How? Why it is not pi by 4? Because this is the complex number. Where it is lying? Can you tell me where it is lying? The complex number -1 minus y. Where it is lying? It is lying in the third quadrant. Yes or no? So this is suppose -1 minus I. This is my complex number z. If I'll join with origin, okay, with origin, then it is its argument will be, see, you can see here, its argument will be pi plus, if this angle is theta, this angle is theta, then the argument of z will be pi plus theta. Okay, if this angle is pi by 4, okay, if this angle is pi by 4, if this angle is pi by 4, then this will be pi plus pi by 4. So see here, it can't be negative. Also we can see here pi plus pi by 4, which is 5 pi by 4. It gives you a negative value. It gives you a negative value. But tan of pi by 4 is 1. Yes or no? Tan of pi by 4 is 1. So it is not argument. So what is the argument of this complex number? We can say. What is the argument of this complex number? Can you tell me what is the answer? You two guys, please respond to the chat box. What is the argument then? If it is not the argument, what is the argument then? Yeah, we can find in clockwise direction also. I already told you in the previous slide also. If we'll move this way, clockwise directions, then this will be minus pi plus pi by 4, which gives you minus 3 pi by 4. Yes or no? Minus 3 pi by 4. So argument is minus 3 pi by 4. Okay. If argument is minus 3 pi by 4, and my tan of 3 pi by minus 3 pi by 4 will be minus 1. So it can't be pi by 4. The argument of this complex number will be minus 3 pi by 4. Is that clear to everyone, guys? Okay. The argument of this complex number can be pi by 4 because this complex number made with positive x-axis, the angle that is minus 3 pi by 4. That's why the argument can't be pi by 4. Clear, everyone? Chalo. Yes, let's move. Okay, now we'll study how we can find the argument of a complex number in different angles, quadrants. Okay, so first we'll consider the first quadrant. Okay, suppose the complex number z, which is x plus iy, which is lying in the first quadrant. Okay, if it is lying in the first quadrant, then the argument of the complex number will be simple. That is, argument of z becomes tan inverse of y upon x. This formula or this method can be applicable when the complex number is lying in the first quadrant. Remember, when the complex number is lying in the first quadrant, then my argument will be tan inverse of y upon x. If it is lying in the second quadrant, what will happen? Anyone can say? Okay, so let's see. If it is lying in the second quadrant, then the argument of this complex number will be, anyone can say? Okay, see, simple thing you can observe here, how we can find the argument of a complex number when the complex number lying in the second quadrant. Clear? So let's see. Okay, suppose here my complex number is z is equal to x plus iy. Okay, if we'll drop a perpendicular from this complex number on the x-axis, then this length will be y, and this length is mod x. Yes or no? If this angle is alpha, okay, then what is the argument? So if you'll try to find in the right angle triangle, which is lying in the second quadrant of the organ plane. Okay, so in the right angle triangle, if I'll try to find tan of alpha, then tan of alpha will be y upon mod x. Yes, so then alpha is equal to tan inverse of y upon mod x. Yes, so this is my alpha, but it is not my argument. It is not the argument. Argument is here. In this case, argument is theta plus alpha. Yes or no? Theta plus alpha. Or we can say pi minus alpha. Or we can say pi minus alpha. Theta, oh sorry, it is not the argument. Pi minus alpha is my argument. So first we need to find alpha, then we can find the theta. Okay, so theta becomes in the second quadrant, theta becomes what? Theta will be pi minus alpha. So theta is equal to, if this is my alpha is actually tan inverse of y upon mod x. If alpha is tan inverse of y upon mod x, then theta becomes pi minus alpha, or we can say pi minus tan inverse of y upon mod x. Remember these things. First, if the complex number lying in the second quadrant, then the argument of that complex number will be theta is equal to pi minus alpha. First, how we can find? First, we'll try to find the alpha, which is tan inverse of y upon x. Right? Is that clear to everyone? See now, in this triangle, right angle triangle, if this angle is theta alpha, then tan alpha will be y upon mod x. I put height upon base. Yes or no? So alpha becomes tan inverse of y upon mod x. But alpha is not my argument. First, we'll try to find the alpha. Then, by using alpha, we can find the argument, which is theta is equal to pi minus alpha. So this total angle is pi now. So if we'll subtract this alpha from pi, then we'll get the theta. So theta is pi minus alpha. Is that clear to everyone? So in the second quadrant, the case is, or the argument is pi minus alpha. I hope this is clear to everyone. Let's consider now, go through the third quadrant. So how can we find the argument when the complex number is lying in the third quadrant? See here, simply first, suppose this is my complex number, and this length is mod y, this length is mod x. Okay, so then if this angle is my alpha, this angle is my alpha, and then what is the argument will be here? Argument will be argument of complex number will be minus pi plus alpha here. So how can you find first alpha? Try to find first minus pi plus alpha is my theta. or theta? Yes or no? So try to find first alpha. So here in this case, alpha becomes tan inverse of y upon x. That is mod of y upon x. If alpha becomes tan inverse of mod of y upon x, then my theta becomes minus pi plus alpha. So argument of the complex number, when that complex number is lying in the third quadrant, then my argument will be minus pi plus alpha. Is that clear to everyone? Clear? You can respond in the chat box. Yes. Clear? So this is all about your to find the argument of a complex number when the complex number is lying in the third quadrant. Okay, clear? We'll move to the next quadrant. That is the last one, which is fourth quadrant. Okay, so when the complex number z, this is my x plus iy. Okay, when the complex number is lying in the fourth quadrant, then what is the argument? So argument will be simply alpha kya hai? What is the alpha here? That is tan inverse of this, tan inverse of y upon x, that is mod of y upon x. Remember, always remember alpha is tan inverse of mod of y upon x. Okay, so what is theta here? Theta is equal to minus alpha. If this angle is minus alpha, if this angle is alpha, then theta is equal to minus alpha. So theta is equal to minus alpha. So when the complex number is lying in the fourth quadrant, then the argument of that complex number will be minus alpha. Okay, minus alpha. Clear to everyone? Yes. Okay, clear? Let's move to the next thing. Is there any doubt? No. So let's now, what we'll do now, we'll summarize all the arguments when the complex number is lying in the different quadrants. So in the first quadrant, what is the argument? In the first quadrant, argument is theta is equal to argument of z, which is theta, is equal to tan inverse of y upon x, right? Okay, but in the second quadrant, argument, what is the argument of the complex number? That is pi minus alpha, or we can say pi minus tan inverse of y upon x, mod y upon x. Is it clear? And in the third quadrant, what is the argument of a complex number? That is argument of z is my theta, or we can say minus pi plus alpha. There, alpha is tan inverse of mod of y upon x. Clear? And in the fourth quadrant, what is theta here? Theta is my argument of z and is equal to minus alpha, or we can say minus of tan inverse of mod of y upon x. Clear, everyone? Okay, so this is the summarization of how to find the argument of a complex number when the complex number is lying in different quadrant. So remember, in the when the it is lying in the first quadrant, then the argument will be tan inverse of y upon x. In the second quadrant, that is pi minus alpha, and where alpha is tan inverse of mod of y upon x. And when it is in the third quadrant, the argument will be minus pi plus alpha, and in the fourth quadrant, that is minus alpha. Theta is equal to minus alpha. Clear? Sure. Let's solve these two questions first. How can we find the argument? Okay, so this question already we solved, but try to find what is the argument in the first question. The first question. Let's solve. Tell me in the chat box, what is the argument of this complex number? Yeah. See, where it is lying in the third quadrant. When it is lying in the third quadrant. So in the third quadrant, what is the argument of complex number? That is theta is equal to minus pi plus alpha. So alpha is equal to tan inverse of mod of y upon x. Okay, so here tan inverse of minus 1 upon minus 1 mod, that is tan inverse of 1. Okay, so if it is tan inverse of 1, then alpha becomes tan inverse of 1, that is pi by 4. Okay, so for the first question, my alpha becomes pi by 4. Then what is the argument of that complex number? That is minus pi plus pi by 4, which is equal to minus 3 pi by 4. So argument of the complex number, first complex number, is minus 3 pi by 4. It is clear to everyone? Is it clear to everyone, guys? Just respond in the chat box if it is clear to all. Yes, clear? Shall I move to the next question? Tell me, what is the argument? Try to find the argument of the second complex number. What is the argument of the second complex number? First, observe where it is lying, where the complex number is lying actually. That is minus 1 plus root 3. Minus real minus negative real axis, then plus. That means it is lying in the second quadrant. Is it or not? Yes. So, second question mein, Z is lying in the second quadrant. Okay. If it is lying in the second quadrant, then argument will be pi minus alpha. Yes or no? So alpha is equal to tan inverse of mod of y upon x, that is root 3 upon minus 1 mod, that is tan inverse of root 3. So what is the value of tan inverse of root 3? How we are using frequently the trigonometric ratios also, and we'll use also trigonometric formula. So trigonometry is the topic which is a very basic topic where we can use in every topic. Calculus mein to we can use vastly. We'll use the formula of trigonometry vast. Okay. So everywhere we are using the trigonometry. So trigonometry ko na don't take lightly. Remember all the formula and all the ratios value. So what is the value of tan inverse of root 3? Can you tell me what is the value of tan inverse of root 3? So for which value of theta, tan theta will be root 3? That is pi by 3, na? Yes, pi by 3. So alpha becomes here pi by 3. If alpha is pi by 3, then my argument of the complex number z, which is equal to pi minus alpha, so pi minus pi by 3, which is equal to 2 pi by 3. So argument of the second complex number is 2 pi by 3. This is your answer. Clear? This is your answer. Got it? Okay. So let's now try to study what is polar form. How we can find the polar form of a complex number. What is that actually? If z is a complex number, x plus iy, then what is, if I'll ask you to find the polar form of this complex number, then it will be r into cos theta plus I sin theta is the polar form of this complex number. How we can find the polar form? Let's understand this concept first. Okay, so see here, if we'll drop a perpendicular from this point P on the x-axis or real axis, okay, then in this right angle triangle OPM, in OPM right angle triangle, okay, so if I'll ask you to find cos theta, so what is cos theta here? So cos theta, this length is x and this length is y. Okay, so cos theta becomes x upon r. If this OP, length of OP is r, if the modulus of this complex number mod z is equal to r, then cos theta becomes x upon r, then theta will be then x will be r cos theta. Okay, so x is r cos theta, and if I ask you to find sin theta, then sin theta will be y upon r. Yes or no? In the right angle triangle, OPM, right? So y becomes here r sine theta. So x becomes r cos theta and y becomes r sine theta. Okay, so we can write also the coordinate of point P is r cos theta because it is x, and r sine theta. Also we can write here the coordinate of the polar coordinate. We can say they are the polar coordinate of the point P. Those are r cos theta, r sine theta. So what is the polar form? And you have the values of x and y. If you substitute these values of x and y in x plus iy, so we know that z is equal to x plus iy. Okay, so in place of x, if you write r cos theta plus I into r sine theta. So if you take r as common, then it will be cos theta plus I sine theta. So this is my actually polar form. Remember, this is my polar form. Z is equal to r into cos theta plus I sine theta is the polar form of this complex number. Clear, everyone? Just respond in the chat box if it is clear to all, guys. Clear? Sure. If it is clear to all, then move to the next thing. Now, it is actually very easy if it is in the form of polar form. If the complex number is given in the polar form, then you can easily say, you can easily find the modulus, the argument, and the conjugate also. Okay, so tell me what is the modulus of this complex number if z is equal to r into cos theta plus I sine theta. So what is the modulus of this complex number? Can you find the modulus of this complex number? Yes, we can find easily, na? Because this complex number is r cos theta plus r I sine theta, right? So how can we find the modulus? The mod z will be r square cos square theta plus r square sine square theta. Yes or no? On root of r square cos square theta plus r square sine square theta. Yes or no? Let me know in the chart box. It is clear? Okay. Then it becomes, if I'll take r square as common, then if you'll take r square as common, let's see, if you'll take r square as common, then it will be r square is equal to cos square theta, r square into cos square theta plus sine square theta. So this becomes on root of r square, because cos square theta plus sine square theta is 1, then on root of r square is r. So modulus becomes r. In this case, modulus becomes r, and easily you can see here, no need to find here. Because if it is in the polar form, then you can say this is my radius. Sorry, this is my modulus r. This is my modulus r. R cos theta plus I sine theta, that is r is my modulus of that complex. Clear? Then what is the argument? How can you say what is the argument? Argument is simple, theta, because here theta is given. Argument is theta. Okay, so argument of theta. If I'll ask you to find the conjugate of this complex number, then conjugate will be r into cos theta minus I sine theta. Yes or no? Tell me. Okay, r into cos theta minus I sine theta. Clear? Okay, so if it is clear to all, let's move to the next thing, that is argument of conjugate. Okay, how can you find argument of conjugate in polar form? Suppose here it is given one complex number, that is z, which is equal to r into cos theta plus r into I sine theta. If this angle is theta, then the conjugate of this complex number will be image of this point in the x-axis, in the real axis. Okay, yes or no? Image of this point in the real axis. Okay, so this will be my conjugate of z, which is equal to r cos theta minus r into I sin theta. Yes or no? So this becomes argument. What is the argument here? That is, okay, so in case when z is equal to r cos theta plus r sin theta, I sin theta, then the argument is theta. But in if we are asked to find the argument of the conjugate of that complex number, then it will be minus of theta, because because conjugate is the image of that complex number in the x-axis. So this is my z bar. Yes or no? So what is the angle made by this z bar with x-axis? That is my minus theta. So argument of conjugate of z is minus theta. Remember, if argument of z is theta, then argument of conjugate of that complex number will be minus theta. Simple. So you can observe here also, if you put in the complex number in place of theta, if you put minus theta, what it will be? R into cos of minus theta plus r into I of sine of minus theta. Then it becomes cos is even function. So minus negative sign will be observed by cos. And always negative becomes positive inside cos theta, cosine. Okay. So then it will be r of cos theta, and we know sine of minus theta is minus sine theta. So this becomes minus r into I sine theta. Okay, so argument is actually minus theta in case of conjugate, conjugate of the complex number. Clear to everyone? So tell me in the chat box whether it is clear to all or not. Okay, so now one homework question for you. Okay, try to solve it and answer here. Solve this. If z is equal to 1 plus cos of 6 pi plus 5 plus I sine of 6 pi plus 6 pi by 5, then find the modulus and argument of this complex. What is the answer? Anyone can say? Just solve it. What is the modulus and what is the argument of this complex? Okay, so take it as your homework question, because we don't have time. Take it as your homework question. Try it after class and come with the answer to the next class. So Saturday will be our next class. Tomorrow we don't have any class. No? Okay, in Saturday we'll discuss the answer of this question also, and we'll start from Euler's form and cube root of unity, and we'll see some properties of argument, properties of modulus, properties of conjugate also. In the next class we'll discuss of this. Okay, so till then, bye bye, take care everyone. Thank you all. Chalo, bye bye. It's time to end your class because we have this class also. You have